Hello, my dear students. This is Raman Rana here, your mathematics teacher, Cambridge International School, Dasua. Today, we will go for the revision of chapter number 10, circles, and for next 2-3 days, we will take the chapter 10 only, circles. Today, we will revise chapter 10, circles. So, we have studied in grade 9 also circles. So the collection of all those points on a plane which are equidistant from a one fixed point called the center of a circle, and this fixed distance is called the radius of a circle. R is called the radius of a circle. We have discussed in detail what are the chords, what is the segment, what is a sector. In grade 10, we will discuss especially the secant to a circle and a tangent to a circle. So what is this tangent and what is the secant to a circle? We have three cases with a circle and a line. Suppose this marker is a line. First case, when this line is non-intersecting, it is not touching the circle, then this is if a line is in this case not touching the circle. Now case second, when this line divides the circle, if this is line L, this is line M. Now this line divides a circle in two parts, two segments. This line M is called a secant to a circle. This line is called secant to a circle. Secant to a circle. So tangent is a special case of secant. Every secant divides or intersect a circles at 2 points. If we take this secant and we bring it towards the one end of circle, if this dotted line, if this is always parallel to secant, and if this point is P, this line, let this line is represented with small p. This is the third case when this line touches the circle. This is called a tangent to a circle. So in detail, in grade 10, we will discuss about the secant and the tangent to a circle. So let's recapitulate the concept of grade 9 also. In grade 9, we have studied if in a circle, if any chord is there, if A, B is any chord, if we have two equal chords, if we have two chords of equal length, if it is given AB is equal to CD, then the angle subtended at the center is always of the angle subtended by both the chords at the center is always equal. So this is a very important property, that here OA, OB, OD and OC, this angle and this angle, they are of angle 1 is equal to angle 2. It's converse. If angle subtended by two chords at the center is equal, then the chords are of equal length. We have also discussed if in a circle, if any chord is there, let PQ is a chord here, and from the center of a circle, if we join the midpoint of the chord, if PM is equal to MQ, then always OM is the perpendicular. If PM is equal to QM, then this angle is always 90 degree. And its converse, if this is given, M angle OMQ is 90 degree, then confirm this M point is the midpoint of this chord. We have also proved that if we have three non-collinear points, there will be one and only one circle which can pass through these three non-collinear points. So how to construct the circle? Even in construction, we have joined these any two sides, and after joining these two sides, we have gone through the perpendicular bisector of these two, perpendicular bisector with the help of the compass, and after going for the perpendicular bisector here, this point is the center of the circle. So we have studied in detail that there is one and only one circle which passes through the three non-collinear points. We have also discussed in detail about the cyclic quadrilateral. If we have any 4 points, that one point is A, one point is B, one point is C here, and one point is D. So any 4 points on a circle, we say that the quadrilateral form is called a cyclic quadrilateral. Now, the properties of cyclic quadrilateral we have explained with the help of the property of circle. If the angle subtended at the center of a circle by an arc is double, then the angle subtended at the other part of the, suppose this angle is here 30 degree, so angle subtended is supposed to be 60 degree. Or if the angle subtended at the center here and other part of the, if this angle is x, this is always twice of x, and whereas these all angles are of same measure, these all angles are of at x. So in cyclic quadrilateral, the important property which we have discussed in grade 9 is that the sum of opposite angle is always 180 degree. If this angle is of 60 degree, so this angle is supposed to be 120 degree. If this angle is of 130 degree, so this angle is supposed to be 50 degree. So always in a cyclic quadrilateral, if any cyclic quadrilateral, the sum of opposite angle is always 180 degree. X plus y is equal to 180 degree, and W plus Z is also 180 degree. Now about the tangents. Tangent to a circle. If we have discussed one activity in detail, that how many lines can pass through this point. So from one point, we know infinite lines can pass from this one point. But there will be one and only one line which is just touching the circle from this point. So this dotted line is called the tangent to a circle, and point P is called the point of contact. So we have two important theorems, 10.1 and 10.2 in grade 10. 10.1 says that if we have from a point of contact, if we join to the center of a circle, then tangent to a circle is always perpendicular to the through the radius from the point of a contact. Whereas the another property, that is the pair of length of the pair of tangents from the external point is always equal. So for tangents we have three cases. First one, if any point is inside the circle. First case, if any point is inside the circle. So any point inside the circle, we don't have any tangent. So no tangent can pass through the point which is inside the circle. Suppose this is a point A here. We cannot draw any tangent. We cannot draw any tangent. If any line which is passing through this A, that line will become a secant, because that secant intersect a circle at 2 points. So the first case, we don't have any tangent which is passing through the point lying inside the circle. Now second case, if a point is on the circle, so when a point is on a circle, we have one and only one tangent which can pass through that point. So we have discussed also that tangent is a special case of a secant. So when in secant it intersect the circle at 2 points, whereas a tangent, when these 2 points reduce to 1 point, we call it is a tangent to a circle. And this point where the line just touches the circle is called point of contact. Here for this tangent, Q is the point of contact. Here P is the point of contact. Whereas the third case, if any point outside the circle, let this point is your L point, from any point outside the circle, we have a fixed two tangents to a circle. We have two fixed tangents to a circle. So the property of this tangents, pair of tangents, is that the length, that AL and LB is always equal. So one example I want to discuss about your tangent to a circle. We have seen a pulley in a well for like we are assuming that the rope which are using on the pulley acts as a tangent. It just touches it behaves, if here is a pulley and the rope is in this way, so this rope is behaving like a tangent. So we will discuss in detail the questions and the concept of the tangent to a circle. So exercise 10.2, question number 13, the last question of the exercise. Prove that the opposite sides of a quadrilateral circumscribing a circle subtends supplementary angles at the center of the circle. So it's an important question. If we are drawing one circle, if O is the center of a circle and a quadrilateral, any quadrilateral, let here we have one tangent and another one, or we can, A is the point similarly so here this is a quadrilateral, let A, B, C and D. So A, B, C, D is a quadrilateral which is circumscribing. It is touching the circle at these points. Let this point is P, this point is Q, these are point of contact R, and this point is point S. So here we want to prove that angle subtended from the opposite sides. We can take the opposite side AD, BC, or we can take the opposite side AB and DC here. So if I am taking AB and DC, then we want to prove that this angle AOB, angle AOB, O is the center, this angle plus angle DOC is always 180 degrees supplementary. To prove, this is a diagram. To prove, we want to prove here that angle AOB plus angle DOC or DOC is equal to 180 degree. That they are both, their sum is supplementary, 180 degree. So we will apply the concept of the length of the pair of tangents. Length of the pair of tangents is always equal. Here A is the external point, AP and AS are the pair of tangents, their length is always equal. We have discussed also, if we join this point of contact with the center of a circle, this angle is always 90 degree. So same here, this angle from point of contact, this is also 90 degree. So same from S, This point is also point of contact, and even R here, R is also the point of contact and make a 90 degree with DC. So here we know that the triangle OPB and BQO, they are congruent triangle, and so angle 1 is equal to angle 2. Similarly, here C is the point of contact, angle 3, let's name this angle 3, is equal to angle 4. From D point, these two triangles are also congruent by RHS. So here this is 5 and 6 angles are equal, and last from A point, triangle APO and ASO, they are congruent. So angle, this is 7 and this is 8. So we have angle, we'll write angle 1 is equal to angle 2, angle 3 is equal to angle 4, angle 5 is equal to angle 6, and angle 7 is equal to angle 8. So we know that the sum of all these 8 angles is 360. It's a complete angle. The sum of all these 8 angles is 360 degree. So here we can start that angle 1 plus angle 2 plus angle 3 plus angle 4, 5, 6, 7, 8 is equal to 360 degree, and we can give the logic complete angle. Complete angle. So here we know that these two angles are equal, 3 and 4 they are equal, 5, 6 are equal, and 7, 8 are equal. So in place of 1 and 2, I can write twice of angle 1. Twice of, this implies that this is twice of angle 1 plus, in place of 3 and 4, I can write twice of angle 4 plus, in place of 5, 6, twice of angle 5, and in case of 7, 8, twice of angle 8 is equal to 360 degree. Now angle 8 and 1 is angle AOB. So here twice of angle 1 plus angle 8 plus twice of angle 4 and 5 plus angle 5 is equal to 360 degree. So here 2 common, in place of angle 1 plus 8 is angle AOD, we can write angle AOB plus 4 plus 5 is angle DOC is equal to 360 degree. So this implies that further we have angle AOB plus angle DOC is equal to 180 degree. So this is the question. So we are applying the concept of the pair of tangents here. So let's discuss again. Here we want to prove that the opposite sides of a quadrilateral the quadrilateral is circumscribing the circle and subtends supplementary angle at the center of the circle. So here we have proved that angle AOB plus angle DOC is always 180 degree. We can also prove that angle AOD and angle BOC is 180 degree. You can prove whatever way you want to prove. So I hope this question is clear to you people. Question number 12. This question is the most important question of chapter 10, circle. So it is very important to first understand the question. Generally, students cram this question and do lot of mistakes. So here, first, in this question, a triangle ABC is given such a way that a circle is inscribed in it with the radius 4 centimeter. So here the distance BD is 8 centimeter, it is given, and the distance CD is 6 centimeter. Radius of the circle is 4. Radius of the circle is 4 centimeter, and BD is 8 centimeter. CD is 6 centimeter. Means BC side is 14 centimeter. So with the help of the properties of circle, we need to find here the length of AC and AB. AB and AC we want to find. What is the length of AB and what is length of AC? So here we know, let this point is E and this point is F. So if this is 8 centimeter, to confirm BE is also 8 centimeter. We know length of the pair of tangents is always equal. Similarly here, if here the CD is 6 centimeter, so CF is also 6 centimeter. Now to find AB and AC, we need to find the value of the length of AE and AF. Let the length here is X, AF is X, so the pair of tangents are always of equal length. Let this length is X. So we want to find the value of X. So first of all, we join all these radius to the point of contact, and we know all are making 90 degree perpendicular. This is the property of the tangent. So all these angles are 90 degree here. From center O, OD, OE and OF are the altitude on the various sides of the triangle ABC. Now the area of triangle, how to find the value of X? I will proceed with the area of triangle ABC. I will find the area in two ways. First, I will apply the Heron's formula, and after applying the Heron's formula, I will join C with O, A with O and B with O, and then frame here three triangles and then find the area of triangles by triangles area is half into base into height. So let's start the solution here. Diagram is given in the book also. So here a triangle, in triangle ABC, the sides of a triangle are, one side is your X plus 6, X plus 8 and 14 centimeter. So according to Heron's formula, area of a triangle is always equal to under root S into S minus A, S minus B into S minus C here. So here A is x plus 6, B is x plus 8 and C is 14. So what is the S here? If we add all, so sum S is the semi-perimeter. S is, we have studied in grade 9, A plus B plus C divided by 2. So in this case here, S is equal to that 2x plus 28 upon 2. Twice of x plus 28 by 2, which is further equal to x plus 14. So this is the semi-perimeter. Now according to Heron's formula, the area of the triangle ABC is equal to x plus 14. X plus 14 is S. So x plus 14 minus 14 is 1 is x. Then x plus 14, S minus B, that is x minus x cancelled, it is 6, and another is minus, that is 8. So we have the area of a triangle. The area of a triangle is equal to x plus 14 into 48x. This is equation number 1. So this is very simple here. This is S here, x plus 14. Now here x, S minus, if the side is 14, then x, 14 minus 14 cancel, x is left. Then one side is x plus 8. So when x and x cancelled, 14 minus 8 is 6, and then x and x cancelled, 14 minus 6 is 8. So multiplying here, it is 48x and it is x plus 14. So area of the triangle with the help of Heron's formula is under root x plus 14 into 48x. Now the next step, join A with O, join A with O, C with O. We have a triangle AOC, B triangle BOC, and angle triangle BOA. So we know that the area of this triangle area of a triangle, this area is also equal to triangle ABC is equal to area of triangle AOC plus area of a triangle BOC plus area of a triangle AOB. So we know the area of this triangle is base into height. Base into height. So this area of triangle ABC is also equal to, in all these three triangles, the altitude, the height of the triangle is 4 centimeter. This is also 4 centimeter, that is OE. This is also 4 centimeter, that is OD. So we are taking common, area of triangle is half. From these three triangles, I am taking half common. Height 4 common, because OA, OF, OD, OE, they are 4 centimeter. Now first triangle AOC, this side is x plus 6 plus second triangle is x plus 8, and the another side, that is 14. This BC is 14. So here we have the area of a triangle, that is 2 into, again here twice of x plus 28. Now here make it very simple. Take common 2, it becomes 4. Inside it is x plus 14. So this is equation number 2. Equation number 1, this is also area of triangle ABC, and this is equation number 2. This is also area of the same triangle ABC. From equation 1 and 2, from equation 1 and 2, we have area, that is under root x plus 14 into 48x is equal to 4. So here is under root, we'll go for squaring both sides. Squaring both sides. We'll get x plus 14 into 48x is equal to, when we square, 4 into 4 is 16, and x plus 14 into x plus 14 here. So 1 get cancelled, 16 divide this side. So here it is 48x upon 16. 16 ones are 16. This is 3x is equal to, so x plus 14 here. So we have 3x minus x is equal to 14. This x I am taking left hand side. So we have left here with twice of x is equal to 14. This further implies that x is equal to 7. So I hope you are clear with the calculation here. This x here is 7. Now what is here? AB is equal to 7 plus 8. 7 plus 8 is 15, and AC 7 plus 6 is 13. So let's recapitulate again all this calculation work. We have to find here AC and AB. I have applied the Heron's formula. One side is 14, this side is x plus 8, and this side is x plus 6. First I have find the semi-perimeter, sum of the three sides divided by 2, which is equal to x plus 14. By applying the Heron's formula, that is s into s minus a into s minus b into s minus c, here we have found that the area of this triangle is under root x plus 14 into 48x. This I have taken your equation number 1. Now by joining AO, BO and CO, I have drawn three triangles, triangle AOC, AOB and BOC. So the area of a triangle ABC is also equal to the sum of these three triangles. So here these three triangles, their area is also equal to, their area of these three triangles is equal to half into base into height, second half into base into height. So I have taken 4 common outside, half common for three triangles, and here I am taking 2 common. So by taking 2 common, we got 4 into x plus 14. This is the second equation. So area of triangle, this ABC triangle, is 4 into x plus 14. So from equation 1 and equation 2, by squaring both sides, this becomes 16. So we have cancelled x plus 14 with x plus 14. So why I am here, this is the important step, why I am taking 2 common, because here we have x plus 14. So here I am making this term x plus 14. So after squaring, it is both these terms, left hand side and right hand side, they are cancelled and our calculations become easy. So dear students, I hope this question is very clear to you. So this is very important question, and I hope now you all are very much confident, or you can solve this question very easily, and don't cram the question. So dear students, work hard, take care of yourself, stay healthy, stay safe, and stay fit. Thank you very much.